Chapter 12, Electricity. Electricity has an important place in modern society. It is controllable and convenient form of energy for a variety of uses in homes, school, hospital, industries, and so on. Okay, we know it very well that electricity are very necessary in all the places. Okay, without electricity, any gadget as well as human life are very complicated. So it is very important to note that electricity are necessary for human beings. What constitutes electricity? Okay, electricity, what constitute? How does it flow in an electric current? What are the factors that control or regulate the current through an electric current? Okay. Which are the characteristics of electricity? Okay. How the in a circuit electricity are passed? Okay. All this we will study in this chapter. In this chapter we are studying that only about the electric current circuit. Okay. In every electric circuit, how the electricity are passed, that we will study in this chapter. We shall attempt to answer such question. We shall also discuss the heating effect of electric current and its application. Okay. All this we will study that only how the electric current get heating effect. Okay. How they due to the electric current, how the heating effect are seen as well as what are its application. Application means uses. Okay. All this we will study now. Okay. Now electric current and circuit. Electric current and circuit. Electric current and circuit. We are familiar with air current and water current. Okay, we know it very well, air current as well as water current. We know that flowing water constitute water current in river. Okay, flowing water. Okay, whenever we see that when a water is flowing, that we say that water current is constituted. Okay, due to the flowing of a water, we will say that water current has passed or can be seen in a river. Okay. Similarly, if the electric charge flow through a conductor, okay, if the electric charge are flowing through the conductor, at that time what we say that there is a electric current in the conductor. Okay. Whenever the electric charge are flow from the conductor, if the electric charge is flowing from the conductor, then and only then we can say that electric current is there in a conductor. In a torch, we know that there is a cell. Okay. What? There is a cell as well as torch. Okay. Or a battery, when placed in a proper order, provide a flow of charge or an electric current through the torch bulb to glow. Okay. What? That flow of charge. Okay. Charge are flowing. Okay. Or electric current are flowing through the torch, due to which bulb get glow. We have also seen that the torch gives a light only when it switch on. Okay, we know it very well. If the torch, okay, or get switch on, if whenever the torch get on, at that time only light get start or glow. Okay, does a switch do? Okay, a switch make a conducting link between the cell and power. Okay, yeah. Switch make a conducting link between cell and bulb. Okay, for that connecting cell and bulb, okay, switch play an important role. Okay, they are connecting which two? Cell as well as bulb. Okay, both of them get connected due to switch. Okay, same way a continuous and closed path of an electric current is also called electric current circuit. Okay, continuous and closed path. Okay, closed path of an electric current. Okay, if the electric current are passing in a closed path on a particular conductor or circuit, okay, that circuit is said to be electric circuit. Now, if the circuit is broken anywhere, okay, if the circuit is broken or damage are seen in a circuit, okay, then what will be there? The current stop flowing and they do not flow. Okay, if the circuit get break or break down from any place, okay, what will be seen that bulb does not grow, and due to which in a circuit current will not flow. How do we express electric current? Electric current is expressed by the amount of charge flowing through a particular area in unit time. Okay, what we are saying that electric current is expressed. How electric current is expressed? Electric current is expressed by particular area. Okay, in a unit time. Okay, in a particular area, how much amount of charge is passing, okay, with respect to time, okay, that is said to be a electric current. Okay, we say it as a electric current. What, once again I am repeating, amount of charge for flowing through the amount of charge flowing through the particular area, okay, in a particular area, amount of charge are passing in with respect to time, then we say that electric current is explained. In other word, it is the rate of a flow of electric charge. Okay, other word we can say that how much rate a electric charge is passing, okay, flowing. Okay, that is also a rate of flow of electric charge. In circuit using metallic wire, electron constitute the flow of charge. Okay, in circuit, if we are thinking about the circuit, in circuit we can see that metallic wire which are passing the electrons constitute the flow of charge, okay, which are constituting flow of charge. However, electrons were not known at a time when the phenomena of electricity was first observed. Okay, first, whenever electricity are observed at that time, electrons were not known to anyone. So, electric current was considered to be the flow of positive charge, and the direction of a flow of positive charge was taken to be the direction of electric current. Okay. So, from that we can say that flow of positive charge and the direction, electric current was taken as a flow of positive charge. Okay, and that is the direction of a positive charge. Okay, due to which the electric current get direction. Okay, wherever the flow of positive charge are passing, that is the direction of electric current. Okay, conventionally in an electric circuit, the direction of electric current is taken as opposite. Okay, direction are taken to the opposite to the direction of flow of electron, which are negative charge. Okay, which are negative charge. Okay, so here you can see that electron have taken negative charge as well as direction of a positive charge, okay, are considered to be the direction of electric current. So from this we can see that if the flow of positive charge are in whichever direction, that will be the direction of electric current. From this we can say. If a net charge q flow across any cross section of a conductor in a time t, then the current I through the cross section is I is equal to q upon t. Okay, it is said to be I is equal to q upon t, where I indicate flow of current or electric current, q indicate electric charge, and t indicate time. Okay, so formula of a current is I is equal to q upon t. Once again I am repeating, I is equal to q upon t. I means what? Current is equal to flow of charge upon time taken. Okay, so that is the definition of electric current. So electric current is equal to flow of charge upon time taken. The SI unit of electric charge is coulomb. Okay, now SI unit of electric charge is what? Okay, coulomb. Okay, electric charge SI unit is coulomb, and which is equivalent to the charge contained nearly 6 into 10 raised to 18 electron. Okay, which is how much? 6 into 10 raised to 18. 6 into 10 raised to 18 electron. Okay, so it has a charge equal to how much? 6 into 10 raised to 18 electron. We know that an electron passes a negative charge also. Okay, electron possesses negative charge. How much? 1.6 into 10 raised to minus 19 coulomb. Okay. So the electric current is expressed by the unit called ampere. Okay, so from this we can say that electric current have a unit ampere. Okay, which unit? Ampere. Ampere is the unit of electric current. Named after the French scientist. किसके ऊपर से नाम पड़ा? Okay, from which scientist it get name? French scientist Andrew Marie Ampere. Okay, it get name from the Andrew Marie Ampere. 1 ampere is constituting by the flow of 1 coulomb. Okay, 1 ampere means what? Okay, whenever we are saying 1 ampere current is there, at that time 1 coulomb charge per second are passing in a conductor or a particular circuit. Then and only then 1 ampere can be measured. So that is 1 ampere is equal to how much? Okay, 1 coulomb per second. Then and only then 1 ampere can be seen. Because here you can see that I is equal to Q upon T. So Q is equal to how much? Okay, 1 coulomb. T is equal to 1 second. So total 1 upon 1 means 1 ampere. Because current have a unit ampere. Okay. So here you can see a circuit, okay, in which there is a cell, okay, as well as electric bulb. Okay, electric bulb you can see it. Okay, ampere. Okay, ampere is there, as well as plug key is there. Okay, plug key is there. Okay, here you can see that this is a what? Okay, this is a cell or a battery. Okay, whatever, because it are flowing a electric charge or it is flowing a current. Okay, so electric bulb. Okay, you can see that electric bulb. Ammeter. Okay, which are there? Ammeter. Okay, here it is ammeter. Okay, this is ammeter. This is battery or a cell. Okay, this is a battery or a cell. This is ammeter. Okay, this is ammeter. Okay, and this is a plug key. Okay, once again I am repeating. Okay, in the whole circuit there is a presence of a cell or a battery. Okay, this is a battery. Okay, so this is the electric bulb. Okay, this is electric bulb. Okay, this is a ammeter. Okay, this is a ammeter, and this is a plug key. Okay, so in a circuit you can see there is a presence of a cell or a battery, present of a bulb, then present of a ammeter, present of a plug key. Okay, so from this circuit is formed. Now 1 milliampere is equal to 10 raised to minus 13 or microampere, which is 1 microampere is 10 raised to minus 6 ampere. Okay, we know it very well. Okay, milli and micro. So from that you can say that 1 small a is equal to 10 raised to minus 13 a, which is milliampere. Same way 1 microampere is equal to 10 raised to minus 6 ampere. An instrument called ammeter measure electric current in a circuit. Okay, instrument, which instrument? Instrument called ammeter, which are measuring a electric current in a circuit. In a circuit, how much amount of electric current are passing? Okay, that can be measured by the ammeter. It is always connected in the series in a circuit through which the current is to be measured. Okay, through which we can see that current is to be measured. Okay, by this electric current is measured. Okay, so that schematic diagram of typical electric circuit comprising a cell. Okay, in which you have seen that there is a presence of cell. In a circuit you have seen that there is a presence of a cell, electric bulb, ammeter and plug key. Okay, note that the electric current flow in the circuit from the positive terminal of a cell to a negative terminal of a cell through the bulb and ammeter. Okay, so whenever electric current is passing from positive terminal to a negative terminal, it will pass from bulb ammeter. Okay, in this circuit. Okay, because in this circuit we have seen that there is a presence of a battery. Okay, one bulb. Okay, one ammeter. Okay, which are measuring a electric current. Okay, how much amount of electric current are passing in a circuit, that can be measured by the ammeter. Okay, and at last you can see that there is a presence of a key. Okay, which will connect the whole circuit. Okay, if the key is off, at that time current cannot be flow or charge cannot be flow from the circuit. Now example 12.1, a current of 0.5 ampere. Okay, so here current is given 0.5 ampere, which is I is equal to 0.5 ampere. Okay, how much? I is equal to 0.5 ampere. Okay, time drawn by the filament of an electric bulb for the 10 minutes. How many minutes? 10 minutes. Okay, it is placed for the 10 minutes. Find the amount of electric charge that flow from the circuit. Okay, so 10 minutes, yani you know it very well. Okay, in 1 minute there is a 60 seconds. So for a 10 minute we are converting minute into second. So it is 600 seconds. Once again I am repeating. Okay, here our current is 0.5 ampere. Time t, okay, which is represented by a small t. Okay, time is given 10 minutes. Okay, so if we convert minute into second, at that time 10 minute is equal to how much? 600 seconds. So we are converting minute into second. So it will be 600 second. Okay, now we have a equation which formula. Okay, formula of a current. I is equal to Q upon T. Okay, in that formula or the equation, we have taken Q as a subject of formula or subject of equation. So we will get Q is equal to I T. Okay, we are getting Q is equal to I T. Okay, once again I am repeating. We have a formula I is equal to Q upon T. Okay, where we have taken Q as a subject of equation or subject of formula. Okay, so our formula will be Q is equal to I into T. Okay, so we have a value of I. Okay, from the data we can see that I is equal to 0.5, T is a 600 second. So if we multiply it, we will get 300 coulomb. Why coulomb? Because charge have a which unit? Coulomb. Current have a ampere and time have a second. So Q is equal to 300 coulomb. Okay, which is the unit of charge. Electric potential and potential difference. What make the electric charge to flow? Let us consider the analogy of a flow of water. Flow of water. Charge do not flow copper wire by themselves, just as water is perfectly horizontal tube does not flow. Okay, so this way you can see that charge do not flow in a copper wire by themselves. By themselves in a copper wire, charge cannot be flow itself. If one end of a tube is connected to a tank of a water, keep a higher lever such that there is a pressure difference between the two ends of a tube. Okay, what we are doing, that one end of a tube are connected to the tank of a water, keep a higher level. Okay, we have taken in a higher level. What will be there? Water flow out to the other end of a tube, due to which we can see that from the higher level water get connected to the lower level, okay, by the tube. Okay, due to which water will come downward. Okay, at the another end water will come flow. For flow of charge in a conducting metallic, okay, for the flow of charge of conducting metallic wire, the gravity of quartz has no role to play. Okay, gravity do not have any role to play. Okay, for that the electron move only if there is a difference of electric pressure. If the electric pressure are there, then and only then potential difference can be seen. So we have to create what? Okay, potential difference. We have to create potential difference or a difference of an electric pressure due to which current will flow. That we say it as a potential difference. Once again I am repeating. Okay, the electron move only. Okay, electron move only if there is a difference of electric pressure. So we have to create electric pressure difference. Okay, we have to create a difference of electric pressure. Okay, then and only then electron will move. Okay, or that difference is said to be a potential difference. Okay, along the conductor. This difference of potential may be produced by a battery consisting of one or more electric cells. Okay, it can be created by the battery. The chemical action within a cell generates the potential difference across the terminal of a cell. Even when no current is drawn from it, when the cell connected to the conducting circuit element, the potential difference sets the charge in the motion. In the motion, you can see that there is a presence of a charge, okay, due to which produce a electric current, and it will produce electric current. Okay, once again I am repeating what when a cell is connected to the conducting circuit, at that time potential difference set a charge motion of a conductor. Okay, there is a potential difference between them, and due to which current will flow from the circuit and produce an electric current. Okay. In order to maintain a current in a given electric circuit, the cell has expanded its chemical energy stored in it. Cell, okay, which are there, okay, that will expand chemical energy, due to which we can see. So, we define the electric potential difference between 2 points in an electric circuit carrying some current as the work done to move a unit charge for a point of a other. Okay, so work done can be seen. Okay? So for that potential difference is what? V between 2 points. Work done upon charge. Okay, W upon Q. So it will be V is equal to W upon Q. And the SI unit of potential difference is volt V. Okay, so SI unit of electric potential is volt V, and it is denoted by V. Okay. From where it has came, its name came from Alessandro Volta, an Italian physics. Yeah, 1 volt is the potential difference between 2 points of current carrying conductor. So 1 joule, okay, that is a work, okay, unit of work, okay, done by move of a charge. Okay, so work done is equal to 1 joule, okay, and charge is also 1 coulomb. At that time we are getting 1 V is equal to 1 joule per coulomb, okay, because we have a formula. Volt is equal to work done upon charge. The potential difference is measured by the means of instrument. Okay, so for measuring a potential difference V or volt, we need voltmeter. For measuring potential difference, there is an instrument named voltmeter, which are very useful for measuring it. Voltmeter is always connected in parallel across the point between which potential difference is to be measured. Okay, so voltmeter is connected with parallel only. Okay, so here is the example. How much work is done moving charge of 2 coulomb? Okay, so the amount of charge Q, okay, is how much? Okay, 2 coulomb. Okay, so it is 2 coulomb volt. Okay, which we said as a volt means potential difference. Okay, so potential difference is given 12 volt. Okay, so we have a formula that V is equal to what? V is equal to W upon Q. So in that formula we have taken W as a subject of equation or subject of formula. So we are getting W is equal to VQ, where V is 12 volt and Q is 2 coulomb. So we are getting W is equal to 24 joule.
We simply have to connect the positive terminal of the cell with any one of the terminals of the bulb. And finally complete the circuit by connecting the negative terminal of the cell to the second terminal of the bulb. The bulb then glows. The word circuit is very important here. In this context, it will be electric circuit. In simple words, it is the path along which an electric current can flow. You can see here that a closed loop is formed. All the terminals of the electric cell and the bulb are occupied. So here the electric current is flowing along a closed path. We say that electric circuit is complete. But how exactly does electricity flow through the circuit? Well, it is difficult to explain how exactly it flows. However, I will try to give you an intuitive explanation of this phenomenon. You will learn more details in your higher grades. Basically, it's said that electricity or electric current is a flow of electrons in one direction. What really happens is that the negative terminal of the cell repels the electrons in the copper wire near it. So the electrons in a copper wire drift away from the terminal. But in the process, they repel their neighboring electrons. Or in other words, they transfer some of the energy to their neighboring electrons. So the neighboring electrons are also pushed away. They in turn further transfer the energy to their neighboring electrons. The process continues and the energy flows throughout the circuit. This flow of electrical energy is nothing but electric current. So these are the two ways to define electric current. This one is more accurate of the two. In reality, electrons don't really travel from the negative terminal all the way to the positive terminal. The electrons merely drift slightly from their rest position and transfer the energy to their neighbors. This is because the wire is a solid object and the density of atoms per unit volume is very high. Hence, there is no space available for electrons to travel all the way through. So it is this electrical energy that travels through the circuit. But how does the energy flow through the bulb? The electrons in the copper wire transfer this energy to the electrons in metal rod connected to one of the terminals. This energy then flows through the rod, through the filament and out from the second terminal. So in this way, the energy is transferred through the bulb. But when the energy flows between the two ends of filament, it heats the filament up, which in turn glows and gives off light. So I hope that you're now clear about how the electricity travels through a circuit.